Well, thank you. I think this is my third meetup here, so I'm really pleased to be able to hopefully make a useful contribution. I work for the University of the Arts London, working with students, so it's a very creative environment. And I've always been interested in the digital side of actually capturing or kind of extending student work that has been made, fashion artifacts. And we have a costume and performance course as well that really aren't doing any digital work or haven't been doing any digital work at all. So that's where my interest in Blender kind of came about. I started looking at photogrammetry and basically capturing real world objects or people or heads, and then being able to kind of do wonderful things like rig them, which is something I've been struggling with for the last 2 or 3 weeks, actually rigging and animating. So that was really useful. So I'm going to do a basic kind of overview of photogrammetry, and it's basically how to capture a real world object. I'm just going to get my slides going here. There we are. So photogrammetry is three ancient Greek words, comes from Greek language, meaning measuring and drawing with light. And it was invented by the French in around about the 1850s to look at topology, looking at building land topology. The software I'm going to be looking at is called Metashape. It's really good. There's a number of free software packages as well, but this is the one that I use most of the time. I've got some links as well that I can give you after, so you can look at other free software as well. You get a 30-day fully featured free trial with this, and it's really kind of easy. So if you download it, make sure you get the standard edition. The professional edition is a lot more busy. It has stuff like GPS, drone tracking, and things like that. So I'm just going to go through, basically what photogrammetry is, and go through the steps of actually creating a model from a set of photos. So photogrammetry is basically creating a 3D model from a set of photos that you've taken in a very kind of standard order to get a 3D model. And this is a photogrammetry rig that's used pretty much as a standard in the film industry and sometimes in the video game industry to be able to capture people and assets, in kind of a few seconds rather than kind of building them from scratch. And here's an example of a character being captured. So you can imagine trying to build a character like this in Blender or ZBrush would take a bit of time, but here with this array of cameras around, say 300 around, all looking at different steps and angles to capture kind of every part of this person. They will all instantaneously fire off and collect about 300 photos that can then be processed to build a 3D model in a fraction of the time that it would take. And then, I mean, he's not in a great pose, but if he was in a T pose, he could be easily rigged and then used as a digital stunt double in a film, which is fairly common. If you've got to throw somebody kind of off a cliff or something like that, you want realistic stunt double, you can do it with a digital stunt double now. And again, in video games too. So one of the most important aspects of getting a good 3D model out of photogrammetry is taking the photos in the correct way. So I'm going to go through just the steps of taking the photos, and then I'll show you the software and actually building the 3D model. So it's important to make sure that you have standard steps around whatever you're whatever you're going to make a 3D model of. So you need a kind of storyline, you need continuity. So you're going to take the photos in a very structured way, moving around your subject step by step. You can mark out, if you're outside, let's say, for example, you would take photos. You could put like pebbles down or markers. So the difference between using a photogrammetry rig and using your phone camera is that you're just going to be mimicking, or a camera, you're going to be mimicking these cameras moving at different steps and at different angles around. Obviously, the problem of having a rig is that it's not very flexible, and it's a lot quicker, but you couldn't take it outside to capture some assets or a kind of statue or something like that. Then the other point is to actually get the angles correctly. So you can see here, I've just kind of done a basic mark out of how you would take the photos. So at different steps around your subject and at different angles. So you're just building data, and that's an important point, that you're not actually collecting kind of aesthetically pleasing photos. You are creating data from your photos. Now, some of the common problems with photogrammetry is using a zoom or zooming in and out on some photos, especially if you're using a phone camera. The software doesn't like the digital zoom, and you'll get kind of pixelation and stuff like that too. So it's good practice to try and keep at a fixed zoom and not move in and out. Also checking for blurry photos. One blurry photo in a set of say 80 photos could be like putting a drop of ink into water. You know, it'll kind of ruin the whole set. And I've actually made this mistake before, where I've run this through, and one photo was a bit blurry. Overexposed photos is quite common, and I see this a lot with my students too. So if you're trying to scan somebody with a bright light, so I've got a light here that was on, that would kind of blow out behind me. Or if you're outside on a sunny day, let's say you get some good lighting conditions from one side, but it would blow out on the other. But you need them to be really kind of consistent all the way around. And I say the ideal lighting condition would be an overcast day, you know, kind of quite diffused, kind of flat lighting. So even if it was sunny and you're outside under a tree or something like that, would work as well, in the shade, basically. Or using daylight bulbs inside. Tungsten lighting, like very yellow lighting, will be baked into the texture of your finished model. So that's just something to bear in mind, and shadows as well. So here, using those principles of kind of stepping at different points and using different angles to kind of position, and cover kind of under the chin and some of the top of the head. I'm going to process a set of 82 photos. So I'm just going to switch over to my software now. So this is the default opening screen of Metashape. Just to kind of go into the preferences quickly, under Tools, Preferences, I'm using the classic theme. It will normally start in the dark theme, so I've switched to classic. So just so you know that if you start this and think, well, this looks different, that's why. And also under Preferences, on the second tab, there's a GPU. I've got a 1080 graphics card, so I'm using a PC. So if you have a graphics card or a good Mac with a GPU, I don't know if there is such a thing, I'm not a Mac user, this will kind of give you a bit more speed as well. So that's where you kind of enable that. The actual steps for kind of going through this are very simple. So I'm just going to go to Workflow, and the first step is either Add Photos or Add Folder. So I'm going to add photos because I've got some mixed photos in here. So I've got all my photos. So I'm just going to click, Shift click, Open. Okay, and you can see now down in this toolbar underneath, I've got all my photos. I can double click and that'll bring up a new tab here. And there you go. And I can zoom in and out using I'm using a 3-button mouse here. I can zoom in and out and look at the photo. But by this point, I should have checked them already just to make sure. And again, you can see they're kind of moving around in a logical order. So with my photos loaded, I'm going to go to the first processing step, which is Align Photos. I'm going to change this to low because it will take a bit of time to process. But this is just to go through the steps. And generic pre-selection may be enabled for you. I would suggest turning this off because what it may do is downsample photos that you're adding in. So turn this off and press OK. What this will do now is try to work out the angle that each photo was taken. If I just pause this, you can see it's calculating thousands of unique pixels in each photo. So let me just resume that. So it can mark out those unique points in each photograph and then compare it between the photos across the whole set that you give it, to then work out the camera movement and start to build up the position of the camera, which will help it give it the 3D model. And there you go, that's finished. So now I've got my first stage, which is a point cloud. So you can see there's part of the 3D model here. And let me just move this down. And so my my camera positions are here. Now this chap was against the wall, so I couldn't move around him as I recommended first of all, but I only wanted to do this as a kind of smaller test. You'll see now all the photos here have got a green tick next to them. That means they've all been accepted because they, I wasn't using a variable focus or anything like that. You may sometimes get an error, or which is very rare, but it might say, well, this photo, some photos found to aligned. If you've got most of them aligned, and let's say these two hadn't, I can just select these, right click, and then select align selected camera, because the previous working alignments would actually help any that hadn't aligned. But that doesn't happen very often, but that's just a little tip to kind of be aware of. I can also, if I click on the photos, it will give me the corresponding point here. And if you want to, you can turn on the thumbnails as well. And you can see kind of where those photos are. So I'm going to turn it off and get rid of this. So that's our first stage. Now, what I really like about this software is that you're just clicking down in logical order. So you're just kind of coming down these 4 steps. So the next stage is now to build the dense cloud. So we're going to kind of build the raw data of the 3D model. Now we've got our photos aligned, and that looks okay. Just one quick point. You see here that there's I've kept to those, that kind of semicircle here, but on these photos here, these are kind of much closer together. That was just to give the software more data, and again done in a kind of continuous order with continuity, just to give it more detail for when it builds the texture at the last stage. Okay, so let me turn that off, and I'll just do workflow and then build dense cloud. Again, I'm going to set this to low, otherwise it may take some time. Yep, okay, and then just set the defaults. Okay, and now that's going to go through because we've accepted the alignment of the photos, and it's happy with that. Sorry. And because it's happy with that, we can be pretty sure that we're going to get a fairly decent 3D model, and that will just process now and start to build up. Let me just go back to my slides here. There we are. So I'm just going to go through that while this is running, and my GPU is starting to kind of wind up now. So we've just looked at the photo positioning there, and that's where we found it on the toolbar. So it's a show thumbnails, and you can see here I'm following the order that I suggested, going around at some steps. But the other important aspect is to have these angles for the camera. So I've extruded these out here to show that I'm kind of capturing under the chin, straight on, and then kind of coming down. So we're collecting all that data, and that's important because I think to look at this as almost a puzzle. So where you don't have a photo, you don't have a puzzle piece, and where you don't have that, you don't have a fully working 3D model. And I'll just show you kind of how that looks. So here's a scan I did on a tripod, and I just went around and this is one of the first scans I did about 5 years ago. But because I didn't do anything on the top, you can see here, there's a massive hole in her head and under her chin and at the back there. So this would have been a good scan. As I say, this is one of my earlier scans, but you end up with just basically a hole because there's no data. One other thing that doesn't happen so much now, but did before, if you're in a, so you can see I've got a mannequin here, and this is one of our labs at the college. It's white and the background is very kind of similar. So it didn't do a very good job of capturing this model, but it did a really good job of building the room around it. Which, you know, surprised me really, because that's never really happened before. So you can actually use this to build environments as well, even when you're not trying to. But you can use the same kind of methods to do that as well. And I think, you know, it's done a particularly good job around here. So you could do some rough environment building. Let's just have a look at the software and see where we are. A few seconds left, okay. So yeah, that's just a kind of important kind of point. Some issues as well would arise from using metallic or glossy areas. So if you've got something that's you know, made of metal or is made of glass or very glossy like ceramic, because of the way the light moves around it, it makes it very confusing for the software. A quick fix for that is to use dry shampoo or talcum powder to give it a matte finish. So that way you can still get your kind of object built. And you can also use tracking points. So because the software is looking for unique points of or pixels in each photo, you can give it some actual unique points. So these are kind of tracking points that have been put into this photo because the head that they're trying to build the model of is white and very plain, quite featureless. So there wouldn't be a lot of unique pixels in that head. So by tricking the software with the tracking points, you're actually getting a scan of the head as well. So that's just one tip. And both of those techniques are being used to scan a car. Obviously, a car is very metallic and has, well, it's basically metal and glass. So they covered this car in a kind of matte substance there, and then put on tracking points to be able to capture it and just get the actual model, and then they can change the material kind of after. So let's just go back, and this should be finished now. Yep, so that's finished processing. One thing I don't really enjoy much about this software is that you have to manually go through and kind of move to the next stage. It won't automatically move there for you. So here I've got point cloud, and I'll just come up to dense cloud here. You can see now we're starting to kind of get towards the 3D model. Because I didn't take any photos over here, the software wasn't really sure what to do. So I deliberately missed out some detail to kind of show you this error. And you can see again, because he was against the wall, I didn't get any photos behind his ear. So it looks okay from this kind of angle, which is where I would have taken a photo, but he's got a big hole. So there are some basic cleaning tools here too. So if I come up to the toolbar, I can just select the circle selection tool. One tip though, let's say you have got a lot of the room built. What I can do is kind of use this wheel to the X, Y, and Z here, and then the middle mouse button to zoom out. With this tool selected, and click draw out, then edit, invert selection, and that would select the whole room. And I could just delete that. Let's say you had like a lot of data like I did in that first photo, and that would get rid of all that data, save you doing it all by hand. All right, so what I'm going to do, I'm just going to do a quick, very quick cleanup on the top of the head there. So I'll just bring that down, change this to a freeform, and then just lasso kind of around that, and then come back and press delete. On the Mac, you'll have to do edit, delete selection. And then obviously I'm going to have some more data here. And I'll just clean this up. I'm just going to do this quite roughly to start with, and just get rid of some of this data that has come out. Now, one other option, if you are getting a lot of background noise, or you're having a lot of problems getting too much noise around, is you can use a masking tool. So I would recommend using like a front side and back photo. So if I just come down here and find that, you see these are all the unique points that have been found by the software. I can go to photo, intelligent scissors. Magic wand will sometimes work, but I found that it's actually quicker to use intelligent scissors, and I can just start to click and draw around. You have to come back to your starting point to close the loop. So just as an example, I'm just going to do this quite roughly. And then I found moving the cursor off the screen gives you a tight kind of loop to the edge. I'll just come down. And basically what I want to do is, let's say the background was giving me a bit of a problem, or I was getting a lot of noise, or it was difficult really to distinguish between your subject or object. I can tell the software, hey, ignore this background. And in this area, I right click, add selection, and now the background's been removed and the software won't look at that option at all. And just to prove that, there's a show mask button here. If I click on that, you can see now where my photo, the others say no mask. You can see the black is to be disregarded and the white will be included in the model. And that can help to give you a clean, a clean 3D model with less noise. Okay, I think that will do for now. So now I'm going to build the mesh, and that is just moving down and selecting build mesh. Now when I've got some, I'm sorry, I'm just going to make sure I've got this on medium. I'm going to set this to low. You can do this to build low poly objects as well, and there is a decimate option in this software that works quite well. So I'll let that run. And I think it's important as well to mention that this actually is using polygons rather than quads. So if you're bringing it into Blender, you might need to remesh it. Point cloud was our first, dense cloud, our second stage, and then we're going to build the wireframe and a mesh. And I don't really need to go kind of into that. I'm sure we all know what a mesh is made up of. But yeah, as you can see here, this is all triangle based or poly based. The UV stuff on here is pretty terrible, to be honest. Natively out of the software, it's not great. And one of the things I need to do is find a good way to a good quick way to do retopology on this. So once we've got the solid model, the last stage will be to build the texture. And it would be really nice if it built the texture like this, a nice clean JPEG wrapped around a nice model. But this is what it actually looks like. So this is a UV from the software. So it's not very clean, and it doesn't kind of unwrap as well as I would have liked. Okay, so that's finished now. And then again, because it doesn't go to the next stage straight away, I'm just going to come up to the Illuminati pyramid here and select solid model. You can see now I've done this kind of low poly, and I've left a lot of this data in. And again, you can see I've got this here because I think I've left on fill automatically. But that can be turned off. But even if you were doing low poly, I know someone mentioned earlier that they were looking, you can get quite a good low poly scan as well without even texturing it. And there is a decimate tool here. So I come up to tools, mesh, and I can just decimate it and then put in a new poly cloud. And it does do quite a good job sometimes, to be fair, yeah. Okay, and then the last stage is just a kind of step down, is build texture. And again, this is just a logical order kind of stepping down. I'm going to accept the defaults and do OK. And you just come back here. I'm going to skip over this, sorry. So these are the stages basically. You know, first stage, add photos, align photos, build dense cloud, build mesh, and build texture, and we just step down in that order. And that's why I kind of like this software. I turned off generic pre-selection here, and if you found that you were doing a scan and you'd missed out some photos, if you left it in place, you could go and take some more photos, bring it back and add those photos to that data set. So let's say on one side you forgot to take some photos or you didn't have enough, and then you could use reset current alignment for those photos to be included again. So it could save you running the whole photo set again. For the mask, I used photo and intelligent scissors, and I just clicked on show masks on the photos toolbar to show where those masks were. And yeah, as I mentioned as well, the software doesn't move through the 4 stages automatically, so you have to manually click through them. And now you can just, once this is done, let's have a look. No, it's still processing. The export option is pretty straightforward. File, export, model, so you can get your model straight out. And you know, the 3 main formats I've used has been FBX, OBJ, and if you don't need animation, OBJ is fine, or STL if you want to 3D print. So this software kind of does all of those. So those points that I've made, basically it can be compressed to 3 points, you know, clear, uniform photos in a structured way, kind of at structured angles, and stable setting and subject. So making sure the environment isn't going to blow out the lighting and or be very dark or very noisy with lots of things moving around. Because if you're trying to scan an object that's moving or a person is moving, then that's going to confuse the software. So that's just something to be aware of. And I was looking at Sketchfab to show you some of those. Let's just go back, and now if I click on model textured, it'll give me the texture view. So you can see now we've got this this kind of fairly good 3D model, except for all the noise that I didn't clean up, from a set of 82 photos. And the photos, to take those with I took them with my Samsung S9, and to take the photos took about 5-10 minutes. So compare that to the building and texturing modeling time, you know, it's a lot faster. And you can put this, you know, easily into Blender and, you know, start to play around with it, create your own texture, or even sculpt it. Now, that was actually my little brother that I scanned. And so I turned him into a devil, and he was really not very happy about that, but that made me laugh. But then the other stuff, let me just show you another scan I did. Because I work at this is a head scan from a member of staff. You can see her hair was moving, so that actually caused an issue there. Students, I don't know why, my students really enjoy looking at people's faces through the back of their heads. They get a kick out of it. I don't know why. This was a leaf sculpture head that was sculpted by one of our film and TV students. So again, I think this is a great way to kind of capture that work rather than having a photo. And it can be repurposed too, this kind of stuff. You can do stuff digitally. You could rig it. You could put an eye rig in, you know, you can extend it. And that's the thing that I kind of really want to do. And just with that in mind, if you've got a camera phone with, if you've got a decent phone that has Instagram, if you point your camera at this link, you'll be able to wear that mask and it will change your color. Eye color too. So that's something you can do. And but I guess this is being recorded anyway, isn't it? So that'll be there. And I think that's kind of it. How am I doing for time? Oh, blimey, I've gone through a bit quicker than I thought. I was rushing through, sorry. Oh, one other thing. Photogrammetry now is kind of, you know, like Photoshop and other software. You know, AI is starting to creep into everything, and these are 3D models made from one photo. So one photo from the front, and it makes the front and the back model. So once AI starts to creep into the software, you know, we'll be able to get incredible 3D models really easily and really cheaply. I think that's kind of it, really. So I am happy to help or assist or give you any backup. I'm on the Blender Slack, so if you do want any help with any projects or anything, I'd be glad to help. And I'm just going to share one last thing. This ties in well with Luciano's talk. I've been driven mad by rigging and animation because I've never done anything like this before. And I had a student that was stuck in China, and her costume was there too. So I taught her how to use photogrammetry to capture her costume. We rigged it, and then we had a dancer using motion capture to then transfer that animation over. This kind of kept me awake at night, but it's moving in a really good direction. And with Blender, we're going to have like animated petals that open on the head and stuff like that. And I think once people start to see this at the college, and that what you can do digitally with real world costumes and how you can animate in Blender, I think it will start to kind of move things along. And I was really pleased. The string things there, I think they're flipped normals, but I still think I'm a bit of a newbie, so I've got to investigate that. So yeah, I think that's it from me. Thank you for your time, and thanks for letting me do this here. Cheers.